you can't, these models we have are really complex, and so what should we do about that? Well, here's another one. I mean, this is signaling, okay? And I can't even think about this without drawing it somehow. I mean, I can try to trace my path through little stories here. And it just goes to show that there's many, many types of ghosts. A lot of them have to do with, it's always a difference in how I have my knowledge organized and how you have your knowledge organized. And that the degree to which that is different is really impossible to measure. But we use language and social constructs to build them and also to communicate them. A lot of ghosts have to do with relationships between ideas. A lot of them have to do with, I'll talk about some of these things. We don't have time to go through them all. But metaphors are really important. Also, styles and genres. You know how long it takes me now about 3 minutes to read and grasp a paper, and when I started it took like 4 hours. And that's just because I know how the information is distributed around and the key things to look for. So here's another example that tells us something very, very interesting about how all scientific models work. I was working with the MRI guys, and we were working on images and descriptions of images, because they would put an image there, and then they would try to translate this image into language and describe it for us somehow. So I told them, go into the kitchen and get an object and bring it back, and look at it, and come back and describe it to us without telling us what it is or what its function is. So they came back and gave these sort of physical descriptions of things. And one of the students chose this, okay? And they described it, but when people drew this, they sometimes drew this. The way they described it was ambiguous, because some people drew this, and some people drew this. And it was a really square one, right? And the reason the person didn't describe it well enough to distinguish it from this is because they didn't even remember that this existed. So the degree of accuracy that you need in order to tell us what SRI is, Y is simply enough to distinguish it from anything else that might be in the set. But you don't know everything in the set, which means implicitly that the way we think about these objects in our systems and the components and their interactions are inevitably wrong in many, many ways, because there's things that we don't know, or they're just things we're not thinking about at the time. And the best way to do this would be, okay, I have to describe this, and everybody knows it belongs in the kitchen. I wonder what else is in the kitchen that they might confuse it with. And if you just go through that process, maybe you can think of it, you can say, okay, is there something in the kitchen that has a similar function, which might mean it has a similar structure? You could get at it that way. There's all kinds of little tricks and paths you can take to get there. So remember that if we redefine our goal and say, I'm not just going to try to tell somebody a story, but I'm going to try to make sure that they interpret it the same way, that it means the same thing to them, then first you have to really see how those things are organized in your own mind. You have to really analyze this little network of ideas and say, okay, if I'm going to tell this story, here are the links that I need to provide, like the machine reading metaphor. So you have to see that. And then you have to make your best guess about how somebody else has their ideas organized. Maybe a student doesn't really know this model, or they don't really understand how the 3 planks of evolution fit together, or how this relates to that. Again, it's how do I think they do? And then find the simplest way to help the other person build this map that you have in your head. And this process of metaphor, this is the last thing I'll talk about. Again, this goes on and on and on. We could do this for hours, but what's really interesting is that a metaphor is not sort of just saying the man is an old tree. So if I say that to you, you have this concept of a man and you have a concept of a tree, whatever yours are, an old tree, the old man, I don't remember, put them together, and you're not just seeing a man and a tree at the same time. It's much more complex than that. You have this network of relationships that defines your concept of man, and you have this little cloud of ideas that define a tree, and you try to put one onto another. And if you do this in science, so a student came to me with another very difficult story, and she had to tell the following story to her grandmother. That was her assignment. In cells, I know nothing about this because I've forgotten all the details except for what I'm going to tell you now, so don't hold me to this, too bad. There's a protein in cells called MAG. I have no idea what it does anymore. There's an enzyme called the glucuronal transferase, which attaches sugars to this. And it attaches a specific sugar called HNK1, and that's recognized by an autoantibody, and it causes an immune disease, okay? And what they did was they reconstituted this entire system in vitro, taking out the substrate, and they found that the same thing happened, okay? That something else, that they would also get the immune response, which means that potentially there's another substrate that's triggering the immune disease that hadn't been identified yet. Yeah? So how do you tell that to your grandmother? Well, when she drew this image, this looked like a hat, and suddenly this entire story came to me, and that is, it's the story of the man and his wife and the bird and the hat, and that is, there's a guy who every morning goes out and buys a cigar and a newspaper and comes home and smokes a cigar. But before he goes out, his wife tells him, is worried about his health, so she says, don't forget your hat. So she sticks the hat on his head, and he goes out. And when he goes outside, there's a bird that's been trained to recognize this hat. And it flies down, lands on his hat, and he gives it something to eat, and then they're all happy. Well, one day the guy is sick, and someone else is there to visit, and the other person says, oh, you don't have to go out, I'll go out and get it for you. So just before the person goes out, the wife says, don't forget your hat. Sticks it on his head. So the question is, who is the visitor, right? And what's interesting about this is every action in this story is a correlate for the scientific story. So the wife, so what you would say is, yeah, I'm trying to understand how this system works, and I'm trying to understand who's receiving the hat. I'm trying to understand why this enzyme is attaching this and how it's recognized. So you can get the whole point across in the right relationships in a completely different way. Skip over this. The point here is just that
we ran out of time.
Okay.
On the WebEx.
That's all right. Okay, good. I just wanted to say this, and that is, if you were to try to learn chess without a board, you might have fun exchanging codes, and eventually somebody will win. And what's interesting about chess is you never actually see the last move. So it would be real hard, I think, to figure out that this notation system represented this game. And actually, I don't know what's happening in our brains when we play this game, but we imagine it a certain way, and it's a complete. So communication is like the chessboard. And you can use it for real important purposes, and that is to practice. You can study the games of the masters, read their papers, and you can also use it to try things out. So the last thing I'm going to say is, when I do this, I've done this by diagramming this, just making a diagram of my knowledge of gene expression. I can play games with it that would never occur to me, and I can pose questions that I never would have thought of in a different way. And what I do is, I made a big version of this, which is even more complicated because I linked it into a few other things. And I go way to the back, and I have 2 darts, and I throw those darts at this board. And wherever they land, UTRs and enhancers, I ask myself, is there any mechanistic or biological connection between those 2 things? That's, for example. And I try to imagine, well, imagine that there were. What would that look like? How would that work? And what's really interesting is that we know now, and I'm just going to make something up right now, okay? We all know that splicing has become a much more important aspect of sort of the transformation from stem cells to other types of cells and so on. And you can build a story via splicing that talks about enhancers and 3' UTRs. Okay, I need to stop before we get kicked out or something bad happens. And I know I'll be seeing some of you, and if you want to discuss any of this later, feel free. And if you have any questions now, and if we can still keep the room for a few minutes.
3 minutes.
Huh?
3 minutes.
Okay. Questions, comments?
I would make the comment that the person that I know that does this better than anybody else that I've worked with taught high school science for 7 years. And I think that the trick to that is, first of all, you have to figure out what all these ghosts are in order to actually get the students engaged. And then secondly, you have to figure out what it is they don't understand about what you told them. So I would argue this whole exercise can be done as a writing exercise. It could also be done as a teaching exercise.
I mean, again, the concept maps and this whole approach comes from that concept that, first of all, redefining the goal, and secondly, teaching is the paradigm for communication success or failure. And they use concept maps now as a test to see whether people learn things. They have them draw a map ahead of time and a map afterwards. And you can also map a text. You can take a text and map it. So I completely agree. And this is a way of looking at things it's a model of how this process works, and to show kind of how the things are connected to each other. And any input into that would be greatly appreciated from all sides.
I think one of the most difficult parts of it is, I mean, you know, one of the things is obviously you have to know your audience. And then if you're writing a paper, you have a very limited number of characters you can put into that paper. And so they're inevitable. You're going to have to leave a lot of those ghosts out because there's just not room for them.
That's true, but what I found is it's less about, so you saw my press release wasn't longer than the other press release?
It wasn't bad.
Yeah, but that's because, I mean, the other one went on, and I just
Oh.
explored a little bit more of that. But it's more about the structure of the information and just making really very strategic decisions about how information is organized. When I revise text, they always get shorter than they were, and they always get much clearer than they were. Because the other thing is that people they're highly repetitive. They don't see the relationship between the language and the structure. And if you do that, you can make it much more efficient. It's almost inevitably more efficient, so less characters.
Yeah, another way of saying that though, or getting at what we talked about, I think, is that, I mean, bad writing aside, a ghost is not a ghost in all contexts, right?
That's true.
So you once you pick your target audience, then you determine what's ghost for them, as opposed to,
But
you know, a general lay audience.
Right.
Right.
And the only thing that's important here is not realizing that there could be a problem at this level makes things really difficult sometimes, and it's real hard to, I think a lot of times a reviewer, some people say this reviewer didn't read my paper at all. I think in a lot of cases it's something completely different going on. The second thing is if you don't realize that the structure of the information is important. I've heard talks where somebody got up and they showed 25 slides that were not logically linked to each other in any way. And that's because the person knew they were talking to their peers who had theoretically exactly the same architecture in their heads and were just plugging things into the right relationships. That person got into real trouble when they were doing their defense. Because the moment you asked them a question that required them to see a linkage that they hadn't been thinking about and had never come up, things fell apart. If you were to ask your students in a PhD defense to explain natural selection, you would get some big surprises.
Oh,
Yes.
no.
Thank you.
Anyway, thank you very
Thank you very
much.